the session.
So good afternoon, everyone. As discussed in the morning by Professor in the session 1 regarding the dynamic analysis, we are going to solve some of the problems regarding the modal analysis as well as the harmonic analysis. So the main purpose of taking this session on the dynamics in the first session was to introduce you all various aspects of designing the robotic structure. So in the session 1, a lot of things on the vibrations were discussed, which were closely related to the design of robotics. So we will solve some of the problems and that we'll see how we can correlate the problems with the robotic structures and robotic design. To start with this problem, okay, so the slide I'll just show. This is the slide which was presented in the morning session. Since it is a 2 degree of freedom structure, we can consider this structure similarly like a robotic arm having 2 links. This K1 is the stiffness of the first link, K2 is the stiffness of the second link, and the motors are attached onto the structure. So the weight of the motor is like a mass M1 and M2. So like this, we can idealize our complete model and we can find out the natural frequency and the corresponding mode shape of the structure. Now here I would like to share one image which represents the base of the structure, and on the top of this the Mitsubishi robot is considered to be fitting on this top plate. So whatever mode shapes we have discussed in the morning, so these are closely related with the structural design which we are doing. In this model, you can see on the top we have a plate, and the vibration of the plate is very important. It plays very important role since it should not coincide with the natural frequency of the motor which we are mounting on the plate. Now to go more in detail, let us consider that the motor which we are using in the robotic arm or the robotic manipulator has some RPM of consider calculator. Let us consider the robotic arm has a motor which is mounted at the base, has RPM of consider, let's say 1000 RPM. So it has RPM of 1000. So if I want to calculate the natural frequency, I'll just simply divide it by 60. So it will become RPS. RPS is nothing but the hertz. So you can see this is the 16.67 is the natural frequency of the motor. So we have to design the structure in such a way that the resonance frequency of the motor or the natural frequency of the motor should not coincide with the structural frequency. So if it happens, then there will be a resonance and the plate will start vibrating. So how it will vibrate, that we are going to see. What are the mode shapes, how it will vibrate, what will be the second frequency, how it will behave in the second mode, that all we are going to see in this session. As indicated by this red arrow, this also shows that. So in this slide you can see Pushpa sir discussed regarding the earthquake analysis, where some base acceleration acts at the bottom or the foundation, and because of which the robotic structure can have the maximum amplitude. So here you can see if there is sudden impact to the base, then because of the impact on the base, the complete robotic structure will vibrate or it will deflect, and because of which the gripper will suffer from maximum deflection. So how much deflection will be there in the gripper can be analyzed using the response spectrum analysis, which is also called as the earthquake analysis. So where the input in the form of acceleration has to be applied. So that we have discussed in the morning. So this was the last image which was shown in the session. So here this is the complete circular plate. Now in this second image you can see this is the rectangular plate. This is the rectangular plate, and we can find the natural frequency of the plate. But here you can see in the image, just open second image. So here you can see we have a circular plate. Now the base is circular, the plate is circular, and we are going to see how the mode shapes are, or how it looks like, that we are going to see. So I just open the PDF so that we all can practice. So I'll say we can have the hands-on. So slowly we will go and we will try to solve this problem parallelly, so that it will closely relate with the hands-on session, and you will be able to solve the problem. So we can start the problem. So the problem is taken from this reference, the mode shape and frequency of the plate element by Lisa. So if you want, I can give the reference in the chat box as well. Analysis type is basically a free vibration analysis. And the type of element which we are going to use are 2D elements. So our main purpose of this analysis is to find out the natural frequency of the plate as well as the mode shapes. These are the material properties. I'll just scroll down. These are the material properties of the plate. You can see here that the plate is made up of steel, having Young's modulus as 36 psi. Everything you can see, everything is in inches. 36 psi is the Young's modulus, Poisson's ratio 0.3, and the density as 0.0007. The geometric properties are like radius is 40 inches and thickness is 1 inch, and these are the boundary conditions. So since we are performing the free vibration analysis, which is also called as modal analysis in some of the softwares, in modal analysis, as we have seen in the first session, in modal analysis, the forcing function is 0. So the equation as well as that the damping is 0. So the equation becomes mx double dot plus kx equals to 0, and we find the natural frequency of the structure. So here there will be no forcing function, only the boundary condition we have to add. These are the boundary conditions. So to start with the problem, I'll go to Feast software. So here I'll just change the color of the background to white so that it will be easily visible. I'll go to colors. I'll go to colors, and here we have this white option. black, white, and customize. I'll click on white. I hope all are parallelly using or doing this hands-on. So here in the main tab, I'll just click. I'll click on the main tab. So here we have geometry, mesh, load boundary conditions, and so on. We have discussed yesterday that we have to follow the sequence. Only then it will be easy for us to give the required inputs and no inputs will miss. So in the geometry tab, I'll click on geometry. So at the start, we have to create a point at the origin. So I'll go to geometry, key point create by on the origin and generate a point. So I'll go to XYZ, which is by XYZ. Double click on the XYZ command, so it will invoke at the left bottom corner, where we have to define the coordinate data as 0, 0, 0, which is the first point. So entity ID, if you want to give, you can give it as 1, or you can keep it blank. So entity ID, you can keep it blank, or else if you want, you can give the name as 1, 1, 2, 3, and so on. Coordinate data, as discussed yesterday, coordinate 0 is for Cartesian coordinate, 1 for cylindrical coordinate system, and so on. So currently we are working in the Cartesian coordinate system. So the coordinate data 0, 0, 0, and click on apply. So in the message box, you can see the command which we have used, the command which we add. And after clicking on apply, it will give the second line, that is point add is done. Now once the point is added, next intention is to create a circle. As you can see here, we have a circular plate. I'll just open the PDF. You can see here we have a circular plate of diameter 80 inches. Everything is in inches. The software is unit independent. The user has to be consistent with the units. I'll just go back to the software. Now our interest is to create a circle. So I'll go to curve. We are still in the geometry panel. In geometry, we will go to curve, create. We go to curve, create. Here we have a circle option. Yesterday for cantilever beam, we have used line option. But now for creating a circle, we use double click to invoke the command. It will get executed in the left bottom corner. Here there are 3 options. First option is the center. We have to choose the center point. The center point we have to choose. So here on the at the middle of this command, we have this option like CPN and so on. So the C stands for the grid point. If you have the grid, you can use the grid. P stands for point, that is the geometric point. N for node, that is finite element nodes. And then here we have snap to corner option, where you can snap it to vertex, point, node, and so on. And this is snap off option, which can snap anywhere onto the screen. So since we have dimensions and we have one point which is created at the origin, I'll use this point filter. And in the center, I have to choose the center point. I'll click on the center. I'll click on the center point, which is P1. And the radius, since the diameter is 80 inches, I will just give the radius value as 40 inches. The radius value is 40 inches. Entity ID, if you want to give, you can give. Otherwise, you can keep it blank. The software will default take it as 1, 2, 3, and so on. Since in our case we have only one circle, the entity ID will be 1 by default. So even if you give or if you don't give, the entity ID will be default 1. So I'll just keep it blank. Once you click on apply, it will generate a circle onto the screen. I'll just repeat the process so that you will not miss the geometry. I'll press Ctrl Z to undo. Okay. In order to create a circle, I'll go to geometry. Curve, create a circle. geometry, curve, create a circle. Double click on the circle command to invoke it, and simply double click on this command. So you can see here this command is activated. Here we have to select the point or the center of the circle. So center of the circle is point number 1, which is nothing but P1. P is for point, N for node, P for point. So point number 1, and selecting point number 1, and we have to choose. We have to give the radius. So we know that the radius is 40 inches, and the entity ID software without default take as 1. And click on apply. So a circle is created. Now, as you see here, we have only a circle, but there is no surface inside. There we have options to create mesh onto the without any surface as well. But since we will, this is our beginner session, so I would like to follow some traditional methods. So I'll go to surface, and go to geometry, surface, create. I'll go to geometry, surface, create, and here we have this using curve option. Geometry, surface, create, using curves. Using curves, we have this bounded option. This bounded means if it is a closed curve, you can simply generate a surface. We have CAD modeling options like lock, sweep, extrude, and glide. Here you can use this bounded option. Double click to invoke the command. Here you can see we have to select the bounded curves. Bounded curve is this curve. So I'll simply click on the curve. So it will show the curve ID as 1. Curve ID as 1. Now, after selecting this curve, the surface will be generated. So the surface has to be labeled as 1, 2, 3, and so on. So here we have this output ID option. So output ID, again, software will default take. If you want to give some other number, you match it with. If you want to keep it black, you can keep it blank. Software will default take it as 1. I'll click on apply. Now on the screen, you can see some dotted lines are represented. Dotted lines are represented. That means surface is generated. This is default, or I'll say we are default in wireframe mode. So I'll just hover my mouse onto the screen. You can see we have some hidden, fill, and shaded option. We have 3 options: hidden, fill, and shaded. So I'll click on fill option, so that it will be filled with some color that will be easily visible to all. Now you can see a surface is generated. Default color is like a brown. So if you want to change the color for better visibility, which like even Hypermesh has the functionality to organize and change the colors and all. So similarly here you can change the color of the surface by simply going to this color tab. We can go to color tab. You can go to color tab. In colors, here we have the surface color. You can see the surface color is brown. Double click on the color, and here you can choose the color as per your requirement. For better visibility, I'll use this blue color, and I'll click on accept. I'll click on blue, click on accept. After accepting this color combination, we have to refresh it. So for refreshing, below Windows option, we have this refresh command. I'll just hover the mouse. You can see this mouse. I'll go to this below Windows. At the top of the screen, you can see there is a menu bar, and there we have this window option. Below Windows, Below Windows, we have this refresh option. You can simply click on this refresh and the color will get changed. Once the color is done, you can go back to the main tab where the surface is generated. Now you can see our geometry is ready. Our geometry is ready. And now I move to another command, which is mesh. You can go to mesh command. Double click on mesh, which will expand the meshing options. Go to FE mesh. As discussed yesterday, we have two options for meshing the 2D surface. So here we have the square element and the triangular element, which is called as triangle element. Triangle element. Double click on quad.
Yes, I think the screen is stuck.
Double click on quad.
Hello?
Okay, just a minute, sir.
Yeah.
Yeah, just a minute, sir. I'll check. Hello? Yeah, is it audible?
Yes, you are audible, but the screen is stuck on the previous command.
The screen is not properly visible. Okay. Yes, sir. Okay, just a minute, sir. Hello. Hello. Now is it visible? The screen is visible now?
Yeah, I'm able to see.
Okay.
Meeting screen now.
Okay.
We are in the FE mesh command.
Yes. Okay. So I'll just repeat the process again. Okay. Once this geometry is done, our next step is to mesh the model. Now to mesh the model, I'll go to FE mesh command. In the FE mesh, since we have 2D surface, or 2D, or we can call it as surface, we have two options. First is the quad and second is the triangular element, which is called as tria. So you can use the quad elements because quad is more widely used because of its accuracy. So these triangular elements are used only as a filler element, where quad elements are not suitable. So I'll double click on quad. Here we have to select the surface. So here are some 2, 3, 4, 5, and 6 options will be there. First option is surface. We have to simply click on the surface. So I'll just go to the geometry, I'll click on the surface, it will select the surface. Once the surface is selected, second option is to give the initial size. Now it depends upon the user either to give the initial size or to adjust the divisions as per the requirement. So there are two options. First option is the initial size. It depends upon the user. If he wants, he can give the initial size. Here we have another option called subdivision. So he can give the subdivision. Third option is the method, which is default power. Power method means it has default auto meshing command. So you can change it to map mesh as well. So methods, we have power mesh and map mesh. So I'll click on map. So it will generate a proper mapped mesh. Even you can keep it power, no issues. Now in type we have this 4 node and 8 node. That means it is a first order and second order. So I'll click on first order. Divisions, you can adjust the divisions. So if you click here default, it will divide the complete age of the circle in 30 divisions. I'll click on apply to check what is the mesh and quality of the mesh. You can see, yes. Hello. Okay. So once the mesh is done, you can see some elements in between near the center are not good. I'll just change the color of the element so that it will be visible properly. I'll go to color tab. Since we have changed the color of the surface, you can see the color of the surface is blue. Similar color we can choose for the elements. I'll double click on and I'll click on accept. Now I think it is properly visible. So you can see the mesh is 30. 30 divisions we have created onto the surface, and this is the mesh which we have got. But you can see this is not the required mesh. It should be a proper mesh. So you can simply click on the division again. So here we have this mouse option in the division. You simply click and use your left mouse button. Use your left mouse button and reduce the size. Reduce the count by 1, that is 29, and click on apply. Now you can check the mesh. Okay, still you can see one triangular element is created, and as we have seen, we are not trying to create any triangular element in our model. We will try to create all 4 elements. So you can see one triangle is still there. So in order to remove that triangle, you can again go back to divisions. You can click on mouse, and this 29, instead of this 29, you can make it 28 by just simply using your right mouse button and clicking on to the edge. So here I'll make the size count as 28 and I'll click on apply. And now you can see the mesh. So this is the mesh which is required in our case. So I will just repeat the process so you can move ahead. Press Ctrl Z. In order to mesh this, I'll go to mesh, FP and quad. Double click on the quad to execute the command. In the surface, I have to choose the surface. So I will simply select I'll click on the surface to select it. The surface ID is 1. Initial size, we have initial size option. If you want, you can give the initial size, or else you can simply adjust the divisions. Method, we have default power method. You can keep it as default because we are adjusting the division. So anyway, we are trying to adjust as per on the user's requirement. Type here we have the 4 noded element and 8 noded element. So this is the first order element, and the higher order element, that is second order element. We'll keep it 4 noded, that is a linear element. Divisions, I'll keep it default, that is 30, and I'll click on apply. So you can see this is the mesh which will be generated, and this is not a proper mesh, I'll say. So to reduce the count, I'll simply click on the division again. Here we have this mouse option. You simply click and use your right mouse button to reduce the mesh count, and you can click on apply. After clicking on this 29, you can click on apply. So you find the triangle is still there in, at the center, which is not required. So again, you can adjust the divisions, and you can simply reduce one more count. You can go back to division option, and you can reduce one more count. You can make it 28, and you can apply. You can click on apply. And then this will be the mesh. Okay, so this is the required mesh for our analysis. Okay. So our meshing is done. Our meshing is done. So I'll just go to the PDF. So our is done. Radius is given. Thickness is nothing but a physical property which we are going to define in the property tab. Now the next step is to apply the loads and boundary condition. I'll go to the software back. Our next step is to apply the loads and boundary condition. So we'll just invoke the command. I'll go to structural, since we are performing the structural analysis. I'll go to load structural displacement and add. Load structural displacement and add. Double click to invoke the command. I'll simply double click. So here you can see the node IDs we have to choose now. Here the plate is completely fixed at the edges. So node IDs, we have to select all the edges, all the nodes present on the edge of the surface. So here we have an option. I'll just forward my mouse onto the option which is called as on boundary. We have this option called on boundary. Above group option, above element group G option, we have this on boundary option. You can use this option to select the boundary. So I'm simply dragging the complete element. You can simply drag complete elements. Only nodes which are on the boundaries will be selected because we are using this filter. So these are all the filters which can be used for our selection. In this, I'm using this on boundary filter. So this on boundary filter will be used for selecting the nodes on the boundaries. So here you can see on boundary filter is used, and node ID is 1 to 8, means from 1 to 28. From 1 to 28 nodes are being selected. Then we have to choose the boundary condition values. So since it is completely fixed, I'll just arrest all degrees of freedom. Since the plate is fixed, I'll arrest all degrees of freedom. I'll click on apply. Since the boundary condition is at the fixity is applied, we have to apply at the edges. You can simply click all degrees of freedom and you can click on apply. And here you can see here auto execution is checked. Auto execution is checked. That means if sufficient data is given to the software, it will automatically execute the command without clicking on this command. So since the nodes and boundary condition values are given, these are all optional. So if you click on apply, it will directly execute the command since auto execution command is on. If you don't want like this, you can simply uncheck it. So from next time, you can simply view the details completely. So here, these are all optional data. Like we can either give the label, boundary condition, name, rename it, you know. Okay, so now the boundary condition is added. I'll go back to this PDF so that we'll check what extra boundary condition is there. Now you can see here in loading, here we have this fixed at the outer edge that we have done. Now second boundary condition is RZ is 0. That means the nodes does not move or does not rotate about its own axis. That is in RZ, rotation about the Z. So you can see our Z is in the out of plane direction, that is perpendicular to the screen. So you are in the same command, you can simply click again on this boundary condition option. You can select nodes as all, since we have to give the boundary condition to all the nodes, and select all the nodes at a time. You can select node IDs as all. In the boundary condition values, now these are the previous boundary conditions. I'll just uncheck all this since we have to give RZ as 0. You can see RZ is 0. So I'll use on the RZ, I'll fix on the RZ, node IDs as well, and then you can simply click on apply. You can simply click on apply. Here you can see auto execution is on, so no need of this further data. It has already applied. Now in the edit tab, you can see there we have displacement constraint. That is nothing but the boundary condition. So we have two boundary conditions. First boundary condition is the plant condition, which is applied at the edges, and second boundary condition is nothing but the we have arrested RZ degree of freedom of all the nodes. So we have 2 degrees of freedom. So in between, if you have applied any other boundary condition by mistake, you can simply delete by clicking on this, and here you can click on delete. It will delete the So in between, if you have any queries, any doubts, or while solving, if you have any issues, warnings, you can please unmute your mic and you can ask the query. Till then, I'll just move on with our further problem. Now the boundary condition is added. First boundary condition is the plant boundary condition, and second is RZ is fixed for all the nodes. Back to this now next. Okay. So now I'll move on to the property section. I'll move on to the property. In the properties, I'll have to define this two, that is the material property and the physical property, because there's nowhere we have given the material property or physical property.
I think there's some network issue at the Aniket's end. I'll just find out and continue. Give me a minute.
Yes. Okay. So now.
Yeah, you're audible.
Hello?
And
Okay. Thank you. So now you can see we have created our geometry, we have meshed, we have applied the loads and boundary condition. Our next step is to apply the properties that are nothing but the material properties and the physical properties. In the material properties, and go to properties, we have to define the structural property, isotopic, and we double click on isotopic. So now we can define the isotopic material properties. So I'll just check what is the material property. Here you can see it is steel. Everything is in PSI inches. So Young's modulus is in PSI. So element IDs. Now we can select, either you can use box selection option to select all the elements, or else you can simply type ALL all to select all the elements. You can type ALL all. And material properties, you can click on the dialog box, so you can define the material properties of steel in PSI. So it is 30E6. So I'll give 30E6. Poisson's ratio is 0.3, and the density is 0.00073. So if you want, you can first write down on some page so that you can give the inputs. So the Young's modulus is 30E6 psi, Poisson's ratio 0.3, and the density is 0.00073. Alpha value is required in case if we are applying the temperature. So the alpha delta T problems can be solved. That is, thermostructural analysis can be done by simply giving the value of this alpha. And this last cell is for the plastic strain versus true stress. This is nothing but the nonlinear analysis data, which is like stress strain data we have to give about the yield point, and then we can capture the plastic strain and the stress values above the yield point. Since we are performing the free vibration analysis, there is no need of this tool. We will simply stick on with the Young's modulus, Poisson's ratio, and the density value. If you want to add it to library, you can simply click on add and you can add it to the library, or else if you want to use for as a temporary data, you can simply click on OK. So it will be added to the material. So once the material is added, the color of the elements will change. This is because the default color setting is on the material properties. You can go to colors. You can go to colors, paint mode. Here you can see in paint mode. You can see now the color is on the material. You can click on default, so it will come back to the default color which we have given. I'll go back to main tab. Now the material properties, I'll explain again what we have done. In properties, material, we are going to structural, isotopic. Elements, we have chosen all, ALL all. And material data, we have simply filled the information here that 36 is the Young's modulus, Poisson's ratio 0.3, and density at 0.00073. And then we have clicked on OK, and the properties have been added to the elements. Now material properties is done. Now our next step is to assign the physical property. Here the thickness you can see in the PDF, thickness is 1 inch. We have to assign the thickness. So in physical properties, I'll go back to the software. You can go to physical. In physical, since it is a 2D problem, we will go to thickness. Double click on add. So you can add the thickness. Element IDs, you can type ALL all. Thickness value as 1 inch. Thickness value as 1 inch. If you want, you can simply label it. I'll just label it as thickness 1 inches. This is just to use for further analysis. Like for example, if it is a big model like ship, where various materials or various thicknesses are assigned to each panel. So in that case, it will be very easy to recognize what is the label of that set or the thickness value. So for now, I'll just label it as thickness 1 inches, and I'll click on OK. So the thickness is added. So again, I'll go to colors, paint mode as default. So we can come back to the default option. I'll press escape. Now in the main tab, you can see we have assigned the material properties and we have assigned the physical properties as well. Now we will just quickly check whether all the inputs we have given are correct. Geometry we have created by going to key point, and then surface we have generated. Then we have meshed it using 4 elements with some 28 divisions. Then loads and boundary conditions, we have assigned 2 boundary conditions. So in the edit tab, you can see this. In the edit tab, you can see we have 2 boundary conditions. First one is the boundary condition that we have applied at the edges, and the second one is the boundary condition we have applied to all the nodes, and we have fixed the RZ degree of freedom. Material properties, we have chosen all the elements and we have given the material properties of steel. Thickness of 1 inch is given to all with label. So here you can see this is the label. Label can be given to any of the entity as per our requirement. I'll go back to main settings, main tab. Now our next step is to perform the analysis. So for that, I'll go to analysis type. As we have seen yesterday and day before yesterday, like we have performed the static analysis. Now our interest is to perform the free vibration analysis. So I'll click on free vibration. I'll click on free vibration and apply. Free vibration is also called as modal analysis in some of the softwares. So you can click on free vibration and you can click on apply. So analysis type will be free vibration. Now, in the analysis type, we have chosen free vibration. So only this free vibration will be highlighted. You can see here free vibration will be highlighted. And go to free vibration. And go to free vibration. So we have to add now some general settings. General settings you can add. So I'll double click on add. General settings are nothing but here we have to extract the number of modes. If you want to see the modal effective mass or the mass participation factor in percentage, so you can request this effective mass to yes. Default number of modes are 20. It depends upon the user how many number of modes he has to extract. It depends upon the degree of freedom as well as it depends upon the geometry. So now in our case, we are extracting number of modes as default 20. So the number of modes the user can extract also depends upon the effective masses. So in the output file, we will get the effective mass. So if it is more than 80%, that means if it is crossing 80% of the total mass, then we can stop extracting the number of modes. So at the start, we can extract 20 modes default. Another option here is the mode extraction, where number of modes can be extracted or the natural frequencies can be extracted within some frequency range. If you know you have some frequency range, then you can simply use this frequency range option. If you don't have the frequency range, but if you are interested in finding the number of modes, you can simply select the number of modes, and here you can set the number of modes. Mass options, as discussed by Kushwa sir in the morning, we have two options: lump mass and consistent mass. So lump mass and consistent mass was defined in this PDF or the PPT. So that PPT I'll be sharing you in the form of PDF in the evening. So I'll use this lump mass. So all the mass is supposed to be concentrated on the nodes in the lump mass condition. And I'll click on apply. So the general settings are done. Now, in the analysis, we have set the analysis type as free vibration. And in the free vibration, we have set the general settings. Some few more settings are available, but that are not used. Those are not used now. But I'll just simply explain what exactly it is. Like FSI data is nothing but the fluid structure interaction data. So if you have on the first day, we have explained like fluid structure interaction in phase is basically a one-way FSI, where the effect of the fluid on the structure can be analyzed and the dynamic characteristics can be estimated. So this is nothing but the FSI data, where we have to give the density of the fluid, height of the fluid, and the contact faces of the fluid. Let us consider if it is the overhead water tank. When it is empty, the natural frequency of the complete structure will be different, and when it is filled with some liquid, the natural frequency will be different. So that kind of analysis can be performed using this fluid structure interaction data. Then the CB matrix also we have discussed, like this is a quick Brampton reduced matrix. So Like the CAD model or mesh model, if you want to send it to any other company, but you want to maintain the secrecy, you can simply export the complete model by the CB matrix. So the matrix can be exported. The user cannot view what exactly the mesh is, how it is, what kind of boundary condition are added, what is the model. They cannot visualize. But the software will understand, and we can, or the software can import, and all the loading condition it will recognize. So this is the good part where you can export the model to any other company by maintaining the secrecy. Okay. So now the free vibration is, the settings are done. We will simply click on run solver now because our almost all settings are done. I'll double click on run solver. So we have not saved the file. So it will ask me to save the file. So I'll just name it as circular plate. I'll name it as circular plate and I'll save it. Once you click on save, it will show the location where the input and output files are available, and the analysis type also it will show. I'll click on yes, it will start solving the problem. If there's any error, it will give in the message box. And similarly, at the right bottom corner, here is the progress bar. It will show the progress of the analysis. So I'll click on yes. So you can see it has started solving, and it has solved in 1 second. So I'll just scroll up. You can see here it has solved in 1 second. It will show the number of substructures used is 1. Number of degree of freedom is 320. So it has solved the problem. Once this problem is solved, you can go to post. Once the problem is solved, you can go to post. In post, you can double click on contours. You can double click on contours. I'll just rotate the screen. I'll just rotate the model by using my left mouse button and pressing the control key. You can see I just rotate the screen by holding control key and using left mouse button. I'll just click on deformed and animate. It will start animating the deflection. I'm simply animating the deflection. You can see on the screen the animation. Yeah. So this is the first mode shape of the structure. Similarly, the second mode can be seen by simply clicking on this mode option. And click on mode option. So almost you can see we have extracted 20 number of modes. So we are getting 20 frequencies. So this whatever animation is there it is first frequency. You can switch on to the second frequency. So 2 modes you will get when you click on the second frequency. So now what is the use of this results or mode shapes which we are getting? So this is the frequency. This is the frequency which is 64.27 Hertz. This is the frequency at which the structure will have the deformation or the behavior like this. I'll just simply orient this model in some left view or right view, now you can see it is moving up and down. We'll try to increase the scale factor to 2 so that it will be visible to all. Now you can see the plate is moving up and down when the frequency of the plate is 64 Hz. Similarly, I'll switch on to the second frequency, where you can see at some particular frequency of 135 Hz, at some particular frequency of 135 Hz, the plate will have the behavior like this. So I'll just explain the first mode in a bit in detail. I'll just switch on to the first mode. So here you can see this is the first mode. The plate is completely fixed from the edges, and because of this frequency, the plate is moving up and down. So now, if you are fitting any of the component, like whatever example we have given in this you can see this is a square rectangular plate, and we have solved the circular plate. But the first mode behavior will be same if it is circle, even if it is a rectangle or any other shape. The deformation pattern will be same independent of the geometry. So even in this case also, the top plate will have the vibrations at top and bottom. So it will move up and down when the frequency will reach to like its natural frequency. Now, if you are mounting any component, if you are mounting a motor, if you are mounting a robotic structure or robotic manipulator on this plate, it is going to vibrate at some particular frequency. So in our case, the frequency is 64 Hz. So if the motor or the robotic manipulator, when it is in operation, when it reaches to, let us consider 64 Hz, that means it is matching with the natural frequency of the plate. And then the plate will start vibrating. And because of these vibrations, because of the movement to top and bottom, it will have the impact, it will have the serious impact on the operation of robotic manipulator, which will occur, which will cause bolts to loosen, or the accuracy of the robot can be, it will, I'll say, it will be badly affected, because even the gripper will start vibrating. So in order to avoid this kind of situations, we have to apply some stiffness, we have to use some stamping on the plate in order to reduce the frequency. So now, to increase the frequency, so our main intention of performing the free vibration analysis is to check the frequency and avoid the resonance. Now, the option to avoid the resonance is to increase the stiffness. So we have to increase the stiffness of the plate in order to increase the natural frequency. Because I'll just here you can see omega is nothing but under root k by m. So we have to, if we have to increase the value of omega, if we have to increase this omega, we have to increase the value of k. K is nothing but the stiffness. Or else we have to reduce the value of mass. But in many scenarios, mass cannot be reduced. So here you can see the thickness of the plate is 1 mm. So there may be some constraints where you cannot remove the mass, but the stiffness can be easily increased by various techniques. Like you can provide some stamping, you can provide some stiffness onto the plate so that the natural frequency will be increased. So while designing the component, we generally design in such a way that natural frequency of any structure is more than 50 hertz. 50 hertz, it may be 60, 70, depend upon the application. If the motor has the frequency of consider 60 hertz, so we'll try to design the rest of the structure in such a way that it will have the frequency higher than this. So we can design the plate having the frequency more than 80 or more than 90 hertz. So I'll just show you one simple example.
One leg means one end, that like that.
Hello. Okay. So I'll just give you one simple example, which is available on YouTube. The link I'll also share the link. So here you can see. Here you can see the experimentation. This is the first mode of vibration. Experimentally, you can see this is the circular plate. This is the circular plate which is clamped on the edges, and it will start vibrating in the first mode. This is the first mode of vibration. You can now simply imagine the first mode, and whatever results we are getting in feast are exactly the same. The pattern you can see, it is the same. Similarly, the second mode can be seen here. The plate has the second frequency. You can see in their case, the second frequency is like 45 hertz. I'll just animate, I'll just play the video. You can see the second mode. This is the experimentation somebody has done. I'm just showing you so that it will be very clear. Now you can see the second mode. I'll just make it full screen. So this is the second mode of vibration. This is the second mode of vibration. This is the third mode of vibration, or fourth mode, I'll say. You can see the vibration, how it is vibrating. So the same pattern can be seen in phase, you can see. So the purpose of this finite element tool is to reduce the experimentation work. So here you can easily model the plate in phase, and you can find out the mode shapes and the natural frequency of the structure. You can see this is the mode shape, whatever we have seen in this video. You can see in this video. So you can see it is vibrating up and down in two halves. So the same pattern you can see for this plate as well. Now, here you can see in this, if we are applying any component, if we are mounting any component on this left side or right side where you can see the red contours, if you are mounting any of the component, and if the frequency of the plate or if there is any resonance, those components which you have mounted on the plate will be severely affected. It will get loosened, or else it will get damaged. So the vibration is very important in robotics design for reducing the structural damage. So whatever problems, like, so I'll just put this one. So whatever problems are taken in the first session in the PPT, you can simply visualize this in the application of robotics, where this is the robotic link 1, robotic link 2, and the mass of the robot 1 and mass of the robot 2, which is lumped. And the natural frequencies can be calculated very easily by simply performing the 1D analysis. So whatever behavior of this 2D plate is there, the same behavior will be there for this square or rectangular plate as well. It will have first mode. The first mode will be similar to the static deflection. It has to be same. So if you are applying some pressure, let us consider if you are mounting some Mitsubishi robot onto this plate, and if it is having some 40 kg weight, and because of this, it will have some deformation. There will be some deformation in the plate. So now you can simply visualize what can be the deformation. It will have bending of the plate. So that same behavior you will get in the mode shape 1. So the mode shape or the fundamental mode is very important, and it should be away from the natural frequency, otherwise it will severely affect the component or the robotic structure. So this is how you can perform the analysis in these for 2D and 1D, as well as for 3D. So if you have any questions, you can please ask. If you have any questions regarding this problem, you can please ask. If it is not solved, or if there are any queries in solving the model or any other queries, you can please ask. We'll try to solve. I would request all the participants to register for the NAFED conference, which will be held tomorrow and day after tomorrow by ISRO. So if you can please attend, that will be really nice, because lot of new developments, lot of new, I'll say, collaborations and modules, new commands, new features. All this will be explored in tomorrow and day after tomorrow's session. So it will be a complete 2D program. So you can please register. You can simply type on Google NAFED or FEAST ISRO conference. You can type, and you can simply register to this event. That will be really helpful for all the colleges as well.
Right. So we are now open for any questions.
There is one question in the chat box. Please provide link in chat box to register. Okay, I'll just email. I'll just email the registration link to all the participants, so it will be easy. I'll email the link to all the participants. So if there are faculties who are interested in development of any of the finite element code, are welcome, and they will be appreciated. VSSC will or ISRO will appreciate the efforts, because there are a lot of scope in the finite element development or code development. So if anybody has worked in the finite element coding, they are they are welcome, and they can approach to VSSC for any of the development. If they have if they have done their PhDs, or if they are doing their PhD, they can approach to VSSC for the code development. So today is the last day. Yes, today is the last day of registration. So within half an hour, you will get the email for registration. So if you have any other questions, you can please ask.
So I don't see any questions in the chat.
Okay.
So I think we will take a break here. We will end this
Yes,
session.
sir.